Hi and welcome to the Edexcel GCSE prediction from On Maths for the Foundation Paper 2. This is filmed after Paper 1. Enjoy! Hi, I'm Chris Gilpin. Welcome to this prediction for Paper 2 Foundation Edexcel. This is the grade 9 to 1. If you're looking for the legacy, I haven't done a video for that yet, but I'm sure by the time you watch this, it will be on the site and it will be on the YouTube ready to go. Now, first thing first, this is a video of all the questions I've done in the prediction. How have I come up with the questions? Well, I've just removed the topics that came up in your paper 1. Now, all the boards, Edexcel included, have said that questions and topics will be repeated, but I think the likelihood of all of them being repeated and your paper 2 being exactly the same as paper 1 is very, very low. The topics I think will be repeated will be ratio, proportion, percentages, things like that are absolutely broad and they can think of loads of different questions about. Topics like cumulative frequency and things like that are unlikely to be repeated. So there are some topics that I would be very surprised if they're repeated again, because there's so many topics that Edexcel want to cover. So this is the best fit. Now, please don't just rely on this paper. Please do all your other revision and just use this paper to see where you're at with your revision and just maybe pick up a few bits and bobs to help you with the exam. This paper is online on maths.com. I'm sure a link will appear somewhere, probably above me. So you can do this paper. Now, the benefit of that is that the numbers are random. So you're not just remembering answers, you're remembering the methods. It will give you a score and a grade. The grade boundaries are my best predictions. They're not necessarily going to be perfect, but they should be roughly correct. And if you sign up, then you can save your scores, so you can try it again tomorrow and see if you've improved. All of this is completely free. There is nothing that we charge for on our site at all the videos or everything. Signing up, the whole lot is completely free. So go to onmaths.com and have a go. Also on the site, there's topic busters for every topic. So this prediction only focuses on a few. The topic busters cover the whole lot. There's also minute marks, which are multiple choice questions that you get a quick answer and you get an explanation of how to do the questions. And a lot of the feedback I'm getting for that is really great, so thank you very much for that. If you enjoy this video, please click like, and if you really enjoy it and want to see more, then click subscribe. I will release a paper 3 after paper 2, so we'll have a paper 3 prediction. Don't forget that paper 2 and paper 3 are exactly the same. They are both calculator, and having said that, make sure you have a calculator. If you haven't bought one yet, which you should have, but if you haven't bought one yet, make sure you get the Casio ones. They are by far the best. And the ones that have fractions and all sorts of things on, they're brilliant. Everything you do now, do with a calculator, because you will have one there, and the more you practice with this thing, the better. I've forgotten where I was, so it's probably a good time to start the video. Thank you. So for this question, you just kind of got to imagine what the shape will look like when it's finished. And the thing that's stopping it from looking perfect is not having this square here. And let's just check it has 4 lines of symmetry when I put that in. So we've got one there, we've got one across here, then we have a diagonal one here, and then we've got another diagonal one here. So it has 4 lines of symmetry. When we're asked to write a number in figures, it just means as numbers. So we've got 5,026. We need a 0 there as a placeholder. So you're just going to write 5026, 5026. Next question says, write down the value of 8. Now, if we remember, and let's just write the number a little bit bigger. This is our units column. This is our tenths column. And this is our hundredths column. So the value of the 8 is 8 hundredths. We can write that as a fraction, 8 hundredths. And that's the answer. Question C, write down 655 correct to the nearest 10. Okay, so 655 If we just do a quick number line, 655, the next 10 up is 660, and the next one down is 650. So those are the two it can round to. This 655 is bang on halfway, and if they are halfway, they round upwards. So the answer is 660. I draw that properly. If it was any less, if it was 654, it would round down. So if the last number, if that number there is 5 or more, it will round up. For this question, we need to understand the difference between multiples and factors. Multiples are just a numbers times table. So the multiples of 5 will be 5, 10, 15, 20, etc, etc. Now every number in the 5 times table ends in 0 or 5. So looking at the list of numbers we've got here, there's only one that ends in a 5 or a 0, which is 10. So 10 is a multiple of 5. Now factors go the other way. A factor of a number means that the number, so 24, is in another numbers times table. So 24, and the easiest way to find the factors of 24 is you start off with 1 and 24, because 1 times 24 is 24. Then you go 2 times, 12, 3 times 8, 4 times, and you think how many 4s? 6. 5 times, well that doesn't work. 6 times we've already got. So those 8 numbers are the factors of 24. Then I look at the list, well, already there's a 24 there. Is there any other ones I could have written? I don't see any other ones, so 24 is my answer there. 2 prime numbers. Now prime numbers mean they only have 2 factors, 1 and themselves. Okay, that's a prime number. If there's any more factors, it's not a prime number. So let's go through the list. 10 is in the 5 times table, which we identified in question A, so that's not a prime number. 24, well, we've listed out 6 other factors of 24, so that's not in it. 18 is 3 times 6, so that's not going to be it. 17, I don't think of any times tables that 17 is in, so I'm going to say 17 is a prime number, which it is. And 19, well, I can't think of any times tables 19 is in, so I think that's a prime number. Let's go through the rest to make sure. So 16 is 2 and 8, so that's not a prime number. And any even number apart from 2 is not going to be a prime number. 2 is the only even prime number. 27 looks like it might be, but actually 3 times 9 is 27, so it's definitely not. And 28 is another even number. So it looks like we found the 2 prime numbers. On this scale on the side of the jug, we're not given the little tiny notches. So the word estimate means that we're not going to get it exactly right maybe, but we're roughly going to be correct. Now there are wrong answers to this. So if I wrote the answer 22, which would be down here somewhere, that's clearly wrong because we know that the water is above 30. We know the water's between 30 and 40. And if you have a look, it's less than halfway. So we're expecting a number that's below 35. I think if you wrote the number 35, you would get that wrong because it's clearly less than halfway. I think the numbers, probably to get it right, you might get away with 34, but definitely 33 or 32. I think personally it's closer to 33, but some of you might look at that and think it's closer to 32, and chances are we'll both get the marks. The easiest way to order decimals is just to put yourself a few columns down the page, and hopefully I'm going to try and get enough columns. I always end up with not enough, so if I put some extra ones in, that should suffice. And just literally put the numbers in, so 14.828, and make sure the decimal points are lined up, so 8.60 is going to be like this, and I'm going to put an extra 0 in to make them all the same length. It doesn't change the number at all. So 14.86, I'm going to put 0 in there. 14.820, and then 14.7. Now we're starting with the smallest. I'm looking for the smallest one first. Well, the smallest one's leaping out because if I just look at this column, there's only one number that has a 0 there, all the rest of them have 1. So the 8.6, 0, and I have to put the 0 because that's how it's said in the question, is definitely the smallest. So we can cross that out. That's definitely the smallest. All the other ones are tied. They're all 1 in that column. So we move over to the left, the next column, sorry, the next one to the right. So 4, 4, 4, 4, they're all tied. So I keep moving along. Okay, there's a clear loser in this one. There's a clear one that's the smallest in this one. The bottom one, 14.7. So that's definitely the next smallest. So I can cross that one out. All the other 3 have tied because they're all 8. So I move on to the next column. Now, looking at this, there's 2 2s and a 6. Now that 6 is definitely the biggest number. So I could fill that in as the biggest number. And we've just got to work out what the smaller of these remaining 2 are. Well, let's move on a column. And you can see here that 14.82 is the smallest or smaller of the 2. And so that leaves the 14.828 in that position. Now always just double check the 5 numbers you've listed are the same as in the question. That's the same. 18.60, that's the same. 14.86, that's the same. 14.82 is the same, and 14.7 is the same. You sometimes lose a mark if you haven't written exactly the same number. Same goes for when there's fractions and decimals. You've got to write down the number that it showed in the question. Alright, so the first place to start on this is to plot the points. So point A is at -3, -2. So along the corridor and up the stairs, well, we're going across -3 on the x-axis, which is this one here, and then we're going to go down 2 on the y-axis. So it's this one here. A really common mistake is to muddle them up. So as long as you remember you're going across and then up or down, obviously if it's negative you go down, then you should be fine. Now it says point A, so I probably should label that as A. And point B is 0, 3. It means we're not going left or right at all. We're just going to stay at 0, but we could go up 3. So it's going to be there. And point C is at 3, -2. So along 3, down 2. Which could be that one there. So that's point C. And it says plot and join these coordinates. So I'm just going to get my ruler and plot and join them. Well, we've plotted them, so we're just going to join them. And there we go, makes a nice little shape there. Now question B says what type of triangle is ABC. So looking at it, it looks like this length here and this length here are exactly the same length. So when we've got a triangle with 2 sides the same length, it's an isosceles triangle. And try and learn the spelling of isosceles, because it does look better when you spell it right. I remember it's ISOSCELES. The SOS is like a Morse code thing to get help, save our souls. So I've always remembered SOS, as in, oh my goodness, I don't know how to spell isosceles. The first thing to look at with a pictogram, which this is the key. Now the key tells us what each picture represents. So if you have a look at the key here, it says each circle represents 8 DVDs. Now that's the complete circle. So it says what day are the most DVDs sold, Monday, Tuesday or Wednesday? Well, or you can always just look at which has the most shapes. Now Tuesday has 2, Wednesday has 1.5, but Monday has over 2, 2 3/4. So it's definitely going to be Monday because it's got the most circles. Now, how many DVDs were sold on Tuesday? Well, if each circle represents 8, there's 8 there and there's 8 there. So we just need to add the 8s together, which makes 16. So 16 DVDs were sold on Tuesday. It says how many DVDs were sold on Monday? Well, you've got the 8 there and you've got the 8 there. Now we've got a bit of a problem here because it's not a complete 8. So we need to figure out how much each quarter is worth. Well, what do you times by 4 to get 8? Well, 2. Let's check to see if that works. So we've got 2 there, 2 there, 2 there, and an extra 2, which is actually missing on that one, would make 8. So that would work perfectly. So to find out a quarter of it, we just divide it by 4, which gives us 2. So we've got the 8s, because we've got 2 complete circles, and then we've got those 3 2s, so we've got another 6. So we just need to add on 6 to the 16. So 16 plus 6 is going to be 22. So that's going to be 22. Okay, let's have a look at the next question. On Thursday, 20 DVDs were sold. Show this information on a pictogram. So let's have a think how many circles that will be. So if I've put one circle down, that's 8. Well, we've still got enough left over. If I put another full circle down, that's 16. Now 16, let's try another one. Let's put another full circle down, and that gives us 24. So that would be too much. So we're going to have to go into those quarters. So we've got 16. How many more 2s do we need? So 16, that would give us 18, and that would give us 20. So we need 2 whole circles and then 2 quarters. So if I shade in, if I draw, then shade in, 2 whole circles, and then we've got 2 quarters left over, which is just a half. Let's just check that. What's half of 8? That would be 4. And what's 8 plus 8 plus 4? That gives us 20. So we know the answer is correct. So we're given a basic formula to work out how long this turkey is going to take to cook. It says that the cooking time, so we can just call that time, is the weight, which it says is a 3 kilogram turkey, and just check that the units are the same, which they are. So it's the 3 times 30, then add 90. 3 times 30 is 90, and 90 plus 90 is 180. Now just double check that it wants it in minutes. Sometimes it'll ask for it in hours. Well, it says it wants it in minutes, so 180. So we're given function machines for this question, and it says what is the output when the input's 24? So the input's 24, and the first thing that's going to happen to it is it's going to divide by 2, so we're going to halve it. So that's going to make it 12. Then it says we're going to add 6. So when we add 6 to 12, we get 18. So the output is 18. Next question says below is a different number machine. It says when the input is 20, the output is 56. So let's follow through on the input. So the input's 20, we go take away 6, so that's going to give us 14. Now we've got to then think, right, how do I get from 14 to 56? Now, as it stands, there are multiple ways of doing this. If you do this on onmaths.com, it has a drop-down box and it only lets you select one of the options. So you can add a number to 14 to get to 56, and for this question that would be full marks, that would be absolutely fine. Or you can times it by 4, and times by 4 is the one I'm going to go for. So I'm going to complete the number machine by saying times 4. With any sequence, the first thing to check is whether it goes up by the same amount. Well, looking at this goes up by 1, this goes up by 3, so it's not going up by the same amount. This goes up by 4, this goes up by 7. But something you might notice is this goes up by 7, and yet there's a 7 here. This one goes up by 4, and there's a 4 here. This goes up by 3, and there's a 3 here. This is what we call the Fibonacci sequence. So the Fibonacci sequence just starts off with 2 numbers, and then we add the previous 2 terms to get to the next term. So we'll add these 2 together to get to the next one. Then we add these two together to get to the next one. So to find the next one, we need to add the 11 and the 18 together. 18 plus 11 is going to be 29. So the next term is going to be the 29th term. Let's just check that's the 6th term. 1, 2, 3, 4, 5. So yes, that would be the 6th term, would be 29. Then we need to add the 18 and the 29 together. And when the numbers get big, if it's not on the calculator paper, you can just add them like this. So 9 plus 8 is 17, and that's going to be 3 plus 1, which is 4. So it's going to be 47. So the 7th term is going to be 47. So always just check that the sequence isn't a Fibonacci sequence before you start to panic and think, what is this sequence? Always check for a Fibonacci sequence. It was just that the previous two terms are added together to make the next term. Make sure that you know the names of the parts of the circles. So a diameter is a line that just goes across a circle going through the centre. If it doesn't go through the centre but it goes across the circle, it's a chord. A bit of a circumference is the whole way around the circle. A bit of a circumference is called an arc. And there's a few more parts of a circle you need to know. Now, on this question, there's a line which touches the circle just at one point, and it's a straight line. The name for that is tangent. When you're rounding numbers to significant figures, first of all write out the number. And with significant figures, you want to draw a line after the second number. So the 6 is the first number, the 3 is the second number. Now, unlike decimal places, you're not looking at counting from the decimal point. You're counting from the start of the number, and we'll have a look at an exception to that on question B. Then we look at this number. Now this number and the 2 are doomed. They're gone. But they're not quite done yet. That blue one has to make a decision. If that number is a 5 or more, that 3 will go up by 1. If it's less than 5, that 3 will stay the same. Now, because it's less than 5, that 3 will stay the same. But have a think about it. If 6,312 people visited or were at a football match, and someone said, "Oh, can you tell me roughly how many that was?" If you said 63, that doesn't make any kind of sense. So the mistake that I've made, and the mistake most people make with this question, is they forget that the 1 and the 2 don't disappear. They turn to 0. So the answer is 6,300. Now on question B, this is an exception that we've got to remember with significant figures. You don't start counting until you hit a number that's not a 0. So the first number is 5 and the second one is 2. So the line will go here. Then let's have a look at our decider number where it's 1 again, so it's less than 5. So we're going to have 0.052. Now I could put 0, 0 in here, but this time the numbers aren't actually affecting anything. Was before, the 2 zeros there were holding that 6 to 6,000 and the 3 to 300, so they were really important. The zeros here aren't actually changing the number at all, so we don't need to have them. So the answer is 0.052. When solving, always just write out the question and put down lines either side of the equals. And what we're looking at doing is doing something to both sides so that we get x on its own. So we want to end up with x equals at the bottom. That's when we know we've solved it. So looking at the left hand side, we need to get rid of this 6 here and the takeaway 6 there. Now we must remove the plus or the minus first, as long as it's not trapped in a bracket or a fraction. So we're going to get rid of the minus 6. To do that, we need to do the opposite of it. So we need to add 6 to both sides. So we're going to end up with 6x on the left hand side, because we've got rid of the minus 6. And we're going to add 6 to that to make 60. Now we want to get rid of the 6 before the x. Now that's a times 6. When you put a number next to a letter, it's a times. So to get rid of it, we need to divide 6. So we're going to end up with x on the left hand side, and 60 divided by 6 is 10. So the answer is x equals 10. Didn't need that much room in the end, and that's it. To answer this question, first of all, we need to know what the gradient is. So what you do is you pick 2 points that you know the coordinates of, which is that one and that one I'm going to pick. Works with any of them. And we work out how much up and how much across it's gone. Well, it's gone 1 up, but I'm going to do this in pence. So I'm going to say it's gone 100 pence up, and it's gone 10 miles across. So to work out the gradient, we're going to do the change in y, so how much it's gone up, over how much it's gone across. Now, some students have that the wrong way around because coordinates work the other way around. You go along the corridor and up the stairs. With gradients, how far you go up or down over how much you've gone right. So that's going to be 10. Now, it says give an interpretation, so we haven't finished answering the question. What does that mean? Well, it means for every 1 mile that we've gone, it's going to cost 10 pence. Now remember, I converted this into pence, so instead of in pounds, it's going to be pence. So the gradient is the cost per mile. And I'm going to put in brackets 10p. Now, it could be that just writing the cost per mile for this question would give you the mark, but if you actually wrote the gradient as well, then you definitely get the mark, and sometimes it will ask you for the gradient and then ask you to interpret it. Okay, so the numbers in this question seem a bit daunting, but the process is always the same with this type of question in ratios. The first thing you've got to realise is, are you given a total amount or are you given an amount of food or amount of drink? Well, it says in total they spend that amount, so it's a total amount. So step 1 is to work out how many parts you have altogether. So for food it's 39, and for drink it's 4. And this will be a calculator question, so why not use the calculator even though we can do it in our head. 43 parts. So we've got 43 parts. The next stage of this is to work out what 1 part is worth. So 1 part is worth how much? Well, you get the amount and you divide it by the number of parts. You're splitting the amount of money between 43 parts. So 11911 divided by 43. And I get £277. So each 1 part is worth £277. Now let's read the question. Find how much money is spent on drink. Well, drink is this one here, and the order which they are in the question, food, drink, is the order which the ratios are. So food, then drink here. So there are 4 parts, so we're just going to write drink. So if each 1 part's worth 277, we're just going to do 4 lots of that. And I might as well do it in the calculator, times by 4. And that's going to be 1108, so 1108. When you're asked to do a plan or a front or side elevation, it's important to remember that the diagram you're going to be drawing must be absolutely square on. So there's not going to be any 3D lines at all. It's just going to be 2D shapes like rectangles. Sometimes you have triangles. Occasionally you might get a circle or a semicircle. So let's have a think. What does plan mean? Plan means view from the top. So what of this shape are we going to see from the top? Well, we're definitely going to see this one. But we'll also see this one as well. Now we've got to work out what the sizes of them are going to be. Well, the top one's easy, it's just 7 centimeters by 6 centimeters. Now I'm not going to be able to draw this accurately because I don't have a ruler, but we can almost get it right. We can get it kind of right. And if I label it, that's going to be 7 centimeters, and that should be 6 centimeters. And in your exam, just make sure you actually measure them, because they are said to you in here, and it does say accurately construct, so you want to make sure that it's done 7 centimeters and 6 centimeters. Now, the difficulty is going to be the last bit. Well, we know it's going to be 6 across because it's the same as this one here, but what's the width going to be? What's this one going to be here? Well, if this one here is 7 and this one here is 9, what's left over? Well, there's 2 centimeters left over, so it's going to be 2 centimeters in width. Ooh. Let's use this one, right? So it's going to be 2 centimeters in width. So 2 centimeters there, and this one obviously is going to be 6 centimeters, the same as the right hand one. Now, this line we have in the middle, this line here, is really important, because that shows that there's a join, that there's something happening there. So you need to construct, you need to show that, especially if there's a change in elevation, just show it with a line on the diagram. Instead of going straight to percentages for this question, I would first of all get it as a fraction. So it says there's 15 students who are female and 31 altogether. So the fraction is going to be 15 over 31. And to simply convert between fractions and percentages, all you need to do is times by 100. And percent means per 100, so it's always going to be times by 100, and that'll always get you a percentage. So I'm going to get my calculator out. Now I can write that as a fraction, or I could do 15 divided by 31. It gives you the same answer. So 15 over 31 times by 100. And it gives me a fraction, so I'm going to press S to D. And it's 48.3870, blah, blah, blah. And it says give it to the nearest percent. So that's a 3, so it's not going to move that 8 up to a 9. So it's just 48%. This question doesn't ask you to show the reasons for your working out, however most of the questions will, so let's try and make sure we write down some reasons as we go. The first one I'd go for is this one here, which I'm going to call A. Now I know that A is 180 take away 115, so 180 take away 100 is 80, take away 15 is 65 degrees, and the reason is it's angles on straight line. And if I know A, I know that B as well. So B is going to equal 65 degrees as well, because it's an isosceles triangle. All the bottom angles in an isosceles triangle equal, assuming that the isosceles triangle has the two same sides on the left and right. Obviously if it's rotated it's not the bottom two angles, but it's always going to be these two angles here. Okay, so B is 65. Now I can go straight to X. Because these are parallel lines, X and B create a Z angle, and we need to figure out what the Z angle is called, but we're going to say X is 65, it's the same as B. Now corresponding is the F one, interior or co-interior or allied angles are the C ones, so the one we've got left is alternate. They're alternate angles, they're Z angles. So the answer I can write is 65 degrees. Okay, so this is quite a tricky question because it mixes fractions and ratios together, but we've got to be comfortable with that. So I'd first of all just show the information so that I can get my head around it. So we've got Denver, who as a fraction has 3/19 of the food, and so that leaves how much? Well, we've got a calculator, so we could just do 1 take away 3 over 19 on the calculator, but we know that that's going to be 16 over 19. So we can kind of ignore Denver now, because we used Denver's amount, or fraction of the food, to work out Engels and Fido's combined. So that's how much food they'll get, but they're sharing it in the ratio of 5 to 2. So in total, the amount of parts they have is 5 plus 2, which is 7. So there's 7 parts altogether. Okay, and each part, so one part is going to be worth, well, as a fraction it's 16 over 19 divided by 7. So 16 over 19 on the calculator divided by 7, which gives us 16 over 133. So that's the fraction of each part. Now it says, show what is Fido's share. So we're looking for Fido's share. Now Fido gets 2 lots of that. So looking for Fido, he gets 2 lots of that fraction. So I'm going to times that by 2 on the calculator, which is 32 over 133. Now it does say show your answer as a percentage rounded to the nearest percent. So to work between fractions and percentages, I just need to times by 100. So what I can do is just times that by 100. I'll do it on the calculator, times by 100, and press S to D if it comes up as a fraction. And it says 24.060 blah blah blah. So to the nearest percent, Fido gets 24%. With two-way tables, we've got to use the totals to work out the missing numbers. So a nice place to start is this box here. If we have a look, we've got a total of 46 people with brown eyes. 23 of them are female. So all you need to do is 46 and take away the 23, and that leaves 23 left over. Now let's have a look at a nice easy one. Right, green eyes, that's a nice easy one there. We've got 48 in total, and 27 females with green eyes. So we want to do 48, take away 27, and that leaves us with 21. Now if we have a look at this one, we have 23 females 23 males with brown eyes, 18 males with blue eyes, and 21 males with green eyes. And we assume that there weren't any others because they're not in the table. So we add those together and that gives us 62 in total. And let's have a look at this one maybe. So we've got 62 females altogether, and we've got 27 of them have green eyes and 23 of them have brown eyes. So we take the 23 and the 27 away from 62, and that leaves us with 12. And we can just check that. We can do 23 plus 12 plus 27, and it equals 62. So we know that's right. With that one sorted, we can get this one. And if there's 18 males with blue eyes and 12 females with blue eyes, that means there's going to be 30 altogether. Now this total is either the total of these ones or the total of these ones, and they should give you the same number. Don't add the blue and the green ones together, so it's only one of them. So 46 plus 30 plus 48 is 124. And let's just check that. 62 plus 62 is also 124. So don't ever write down 248 because that's not correct. So in total there are 124 people whose eye colour were checked. It's important that we're comfortable with converting between ratios and fractions. So having a look at this question, there's red on the first one is 8 and blue is 17. So for every 8 red there are 17 blue. And it's asked us for the fraction that are blue. So there are 17 blue, so 17 goes at the top of the fraction, but how many are there all together? And so it's tempting to put 17 over 8, but it's all together. The bottom of a fraction is the total, so we need to do 8 plus 17, which is 25. So the fraction is going to be 17 over 25. Okay, the next one asks us to work the other way. So we've got green to black counters, and there's that fraction that are black. So there's a couple of ways of doing this. I could write down them as fractions actually. So why don't I try that? So we know that there are 4/7 that are black, and we know that there are only green and black, so there must be 3/7 that are green, because it has to add up to 7/7, which is 1. So looking at that, what we can do to both sides, and I can put little lines down here, I can times both sides by 7 to simplify the fraction, to simplify the ratio even. So when I times the left by 7, I get 3, and when I times the right by 7, I get 4. So the ratio of green to black, and be careful that you have it in the same order, so we need to have green then black, is 3:4. And make sure that it's in simplest form, which it is. Okay, so this question's about an adult and 2 children. So we've got David Smith and 2 children. So there's 1 adult and 2 children. But the prices shown are not quite right, because there's a discount. There's a 5th off adult price and 30% off the child price. So let's work out the adult price first. So a 5th off. Well, first of all, let's work out a 5th of £70. So to work out a 5th, you can just divide 70 by 5. Now I know that 10 5s are 50 and 4 5s are 20, so that's going to be 14. So that's going to be £14 he gets off. So therefore the price will be the £70 take away the £14. So 70 take away 10 is 60, take away 4 is 56. So he's going to pay £56 himself. Let's do the child price. Okay, so it's 30% off the child price. So we want to do 30% of £37. Okay, let's do the equals down here to give us some room. Well, I know that 10% is going to be £3.70, and then I need to times that by 3. Okay, so I could just times it by 3. Let's have a think. I could do 370. I could do it in pence, and then just times that by 3. So 370, and then I can just do times 3. So I can do a little grid. And if this is on the calculator, then obviously you just type it into the calculator. And obviously that's going to be 0, so we don't need that one. So that's 900. That's 21 with a 0. So 900 plus 21, 210 even. 0, 1, and then 11. So that's going to be £11.10. And so we want to work out the price. So it's going to be £37, take away £11.10. So if you take away 10 it's 27, take away 1 is 26, take away 10 is £25.90. Now that's for 1 child, so that's 1 child. So if I want 2 children, I want to do £25.90 times 2. Now I know 25 times 2 is 50, 90 times 2 is £1.80, so that's going to be £51.80. Okay, I'll move down a bit, and let's do the total. So the total is going to be the adult price, which is this one here, plus the 2 children price, which is that one there. So I want to do 56 plus £51.80. And again, if you've got a calculator, you can just type it in, but let's do the column method. £1.80, and then people like putting the zeros in. So that's going to be 0, 8, 7, 10. So that's going to be £107.80. So it's £107.80. Finished. So you'll need a calculator for this question. The different calculators do things slightly different, but by far the most common calculator, and if you haven't got one, I would recommend them, are the Casio calculators. Mine has a shiny solar panel on the top, but you don't need that. The average battery life lasts way longer than you'll ever need the calculator. So the first button I would press, and there's different ways of doing this question, is the button to get the fraction, which on the Casios looks like this, and that will make a fraction appear on your calculator. Now some of the older ones, the fraction looks a bit weird. It involves like a symbol like this, and actually on the new ones it can, but you need to change the settings. If it does that, it should open up, it should look something like this, like a box and then another box, and there should be a cursor blinking in this box. Okay, so we want to fill in this top box first since it's already flashing. So 76.8 plus 81.9. Okay, and so to shift downwards on the Casio calculators, there's a sort of cursor, like a cursor stick, a direction button thing. It's the big blue button beneath the screen on most of the calculators, and you just push the down to go to the denominator of the fraction. And then we need to fill in this bit here, so 0.19, and then to get the squared button, it's on like that. So you just press that, and it looks exactly as it does in the question on the screen, so you know you've got it right. So you press the equals, and my one comes up with 4396.121884. Now it might be tempting to try and round that, but it says it wants all the figures, so just put them all in. Now if your calculator is set to a mode which is going to show even more numbers, then normally six digits after the decimal point is more than enough. They won't require you to go to 100 or 200 decimal places. On this question, that's actually an exact amount. Okay, so write down correct to two significant figures. Now to do two significant figures, we start counting at the start of the number. So I'm going to do a red line where you need to start counting. And you just count 1, 2 numbers. So the blue line is where I've stopped counting. Now all of these numbers here are going to be reset to 0. They're going to go away. Well, not quite. Let's come to that later. Now, this number here, the 9, is what we call a decider number. Now, that number is going to go. That 9 is gone. Okay? But before it goes, we need to see whether that is 5 or more or 4 or less. If it's 5 or more, it pushes that 3 up to a 4. So the answer will be 4, and then you'd think, oh, okay, that's it, rounded, and you'd write that in the answer column. But when I said they disappear, they don't quite disappear. All the numbers above the green line that I've just drawn reset to 0. They turn to 0. Now, if you think about it, if I don't know what would have a decimal place, but if you have a number 4,396.121884 written down, and someone says, "Can you tell me roughly how much that is?" Then if you say the answer of 44, that's not roughly 44. It's nowhere near 44. So the 9 and the 6 will turn to 0, and actually the other numbers do too. But these numbers here are not changing the number at all. These 2 zeros here will make that 4,400 instead of just 44. The other numbers after decimal point, we might as well get rid of them. So the answer is 4,400, okay, because we don't need to show these numbers. Now the reason students make this mistake is they're so used to decimal places. Now decimal places, you always remove them because they're always after the decimal point. But with significant figures, they need to turn to zeros. So this question looks quite complicated at first, but actually there are two very simple-ish ways of doing it. We've got two decagons, and so that means they are 10-sided. And you can just count the sides if you want, but if it says it's a decagon, I trust it, it's a decagon. Now what we can do is we could work out the interior angles of the decagons. Well, they'll be the same, so I can just work out one and then double it, and then take that away from 360 to work out A. And that's absolutely fine, that'll get you the right answer. A quicker way maybe, and especially on the non-calculator paper, but it works on both papers, is to draw a line up here and realise that you've got two exterior angles there. And the beauty of exterior angles for polygons is they always add up to 360. So to work out the exterior angle, always write down what you're working out. All you need to do is 360 divided by the number of sides the regular polygon has, and they have to be regular, otherwise you can't just divide them because we're assuming they're the same. So that's 36. So if that one's 36 degrees there, and that one's 36 degrees there, then all you need to do is 36 times 2. Well, 6 times 2 is 12, 30 times 2 is 6, so that's going to be 72. So let's show the examiner that. 36 times 2 equals 72 degrees. So this question says there's a tennis tournament being played where each player plays each other once. And there's multiple ways of doing this. One of the ways is listing out all the different combinations. But this question only asks for how many tennis matches are being played. So you don't need to list them out, and sometimes you will need to list them out. This one you don't. So let's start off with a lyre. A lyre has 4 people that they're going to play against. William, Paul, Samantha and Christine. William, well, we've already counted a lyre's match with William, so William only has 3 left that he can play. Then Paul we've already counted his match with the other 2, so he's only going to play Samantha and Christine, other than his matches we've already counted. Samantha, well, Samantha's only got Christine left to play after we counted all the other matches. And Christine, well, Christine's matches have already been counted so far. So, we've got the 4 matches a lyre's going to play, 3 matches that William's going to play, not counting the one we've already counted from a lyre, plus the 2 Paul's going to play, plus the other one that Samantha's going to play. So 4 plus 3 is 7, plus 2 is 9, plus 1 is 10. So in total there are 10 different matches going to be played. Okay, for Venn diagrams it's really important to understand the notation. This symbol here means union, it just means or. It means it can be in A, or it can be in B, or it can be in both. So it's any number inside either circle. So I could have 9, 5, 3, 7, 18 or 2. Let's go for 9, but the other 5 would be correct. This symbol here, I always view it as an and. I always put a little line there to say A for and. And it means it needs to be in A and B. It can't just be in A, it can't just be in B. It needs to be in both. And there's 2 numbers that fit that bill, 3 and 7. So I could write 3 or I could write 7. Now this little symbol here, okay, and it's an A with a dash. That dash there means not. So we're looking for numbers that aren't in A and are in B. Well, let's have a look at where not A is. Well, it's anywhere around here. Anywhere around here is not in A. And let's have a look at where B is. So B is anywhere here. So the numbers that overlap both of those are the 18 and the 2. So it's 18 and 2. So there are 2 numbers that fit that bill. So that will go at the top of our fraction. And there's 1, 2, 3, 4, 5, 6, 7, 8 in total. Now I can simplify that a little bit to make it a quarter, and so my answer to that will be 1/4, or a quarter. Okay, so this question, it looks like a standard bearings question, but something you might notice is there's no angles in it. So if there's no angles in it, we need something else, and that something else is going to involve the right angled triangle here. So we can see there's a right angled triangle here, and we know that when we've got right angled triangle, we've got two sides, we can find an angle with trigonometry. I'm going to call this angle x. Now to find x, we need trigonometry, and to do trigonometry, we need to label the sides. So we've got the opposite here, which is opposite the angle we want. We've got the adjacent here, and we've got the hypotenuse here. Well, the hypotenuse is no interest. We're not looking for it, and we're not given it. So it's O and A. So writing SOHCAHTOA, SOHCAHTOA. Well, we're not interested in the H, so it's not going to be SO, and it's not going to be KA, so it's going to be TOA. So TOA stands for tan x equals opposite over adjacent, and the opposite is 47, and the adjacent is 72. Now we want to work out what x is, so to do that we want to inverse tan both sides. Okay, let's just scroll down. Okay, so on the calculator you want to click shift or the equivalent on your calculator and then tan, and then you press the fraction button, 47, and go down, 72. Just don't forget to close the brackets. Every time you click tan or inverse tan, it opens the set brackets. Just make sure you shut them. Let's press equals, and that equals 33.1356, blah blah blah. Okay, let's have a look. So x is 33, but we still haven't got a bearing. What we can do is work out what this one is, and I'm going to call that y. So to work out what y is, it's going to be 33.1. Well, we're looking for nearest whole number, so let's call that 33. And then we're going to add the right angle here. Now, the reason I know this is a right angle here is because it says that he heads west and then south. So I know that both the angle here and the angle here are going to be right angles, because the angle between all four, north, east, south and west, all four directions are going to be right angles. So I'm going to add 90. And you can do this in the calculator, or you can do it in your head. I'm going to do it on the calculator. 123. Okay, now bearings, something that we've got to remember, are always from north going clockwise. So it's always going to be like that. It's going to be that angle there. So to do that, we're going to do 360. We're going to take away the 123 because that's what we don't want. So on the calculator, 360, take away 123, and that's 237. So the answer is 237 degrees. Okay, so tree diagram question, and this one says that in bag 1 there are 3 blue counters and 4 red counters, and in bag 2 there are 4 blue counters and 3 red counters. So with tree diagrams we always start here, and we ask ourselves, well, in bag 1 we can either pick a blue or a red. Well, let's start with blue. What's the probability I pick a blue? Well, there's 3 blues and there are 3 blues and 4 reds, so 7 in total. So we move on. We've picked a blue from bag 1, so we're currently here, And we look at bag 2. Well, in bag 2, there are 4 blue counters and 7 in total. Let's go back a little bit. Let's go back to if we picked a blue in bag 1. Well, we could have picked a red in bag 2. So there are 3 reds and 7 blues. Now let's go all the way back to the start and let's pretend we picked a red from bag 1. Let's have a think. What's the probability? Well, there's 4 red and 7 in total. And a blue from bag 2, well, that would stay the same, wouldn't it? Because there's still 4 blues and there's still 7 altogether. And there's 3 reds and 7 altogether. And that would be enough to get you full marks. Let's move on to the second question. It says work out the probability that 2 counters picked are of different colours. So let's follow the paths down. If I pick this one, so a blue, and then a blue, I've ended up with a blue and a blue. Well, they're not different colours. So let's try another line. So if I pick a blue and then a red, well, that's a blue and then a red. So we want that one. Let's start going down here. So I pick a red from bag 1 and then a blue from bag 2. Well, that's the one we want. And let's try the last one. So a red from bag 1 and a red from bag 2. Well, they're not different colours. So it's these middle 2 we're interested in. It's that one and that one. Now the way of working out the probability of ending on either of those is just to write down the fractions that you passed to get there. So I passed this one, so 3 over 7, and I passed this one, so another 3 over 7. And then what you do is you times them. Now to times fractions, you just times the tops times the bottoms. So 3 times 3 is 9, 7 times 7 is 49. Let's do the same with the red and then blue. So we passed a 4 over 7, and we passed another 4 over 7. And let's times them. So that's going to be 16 over 49. Now, this is the problem, is we end up with 2 fractions. Well, we need one answer. So we need to find some way of combining those together. And in probability, we use the word or. It can either be that one or that one. And any time you use the word or, what you're going to do with the fractions is just add them together. Now, the beauty of this is normally you're going to end up with lovely denominators that are the same. And when the denominators are the same, all you need to do is add the numerators. So 9 plus 16 is 25, and the bottom stays the same. So it's 25 over 49. The easiest way to answer this question on the calculator paper is to think in terms of multipliers. Now multipliers are a nice easy decimal you times something by to do whatever the question's asking you to do. So either increasing it by a percentage or decreasing it by a percentage. So if we ignore the second part of the question, just focus on this bit, 11% off. We always start off with 100%, always. And 11% off would have taken away 11% from that. So that's going to leave us with 89%. Now 89% is not a multiplier yet. All you need to do is divide it by 100 to make it a decimal. So in your calculator or in your head, divide it by 100 and you get 0.89. And that's a multiplier because all we need to do is put any number in here, we times it by 0.89, and it gives us what the new number is with 11% taken off. But the difference with this question is we're not working this way, we're working this way. So if you have a look at the question, it says the sale price is 917, work out the price of the TV before the sale. So the end price is 917. So instead of timesing it by 0.89, when we're working the other way, we divide it by 0.89. Now I show it this way round because I like to have it in the middle, but we've got to do 917 divided by 0.89. Don't do 0.89 divided by 917, otherwise it won't make sense. So on the calculator, 917 divided by 0.89 and press equals. You might get a fraction, just press S to D. And we get 1030 pounds 34. So I've rounded that to the nearest penny, because the next one along, it's 337, so the 7 pushes that 3 up to a 4. And so that's going to be 1030, so 1030 pounds 34. Let's see if that makes sense. Well, it kind of makes sense that it's gone down a little bit to 917 pounds. So the actual thing makes sense. We'd expect the price before the sale to be higher than the price on the sale. Something you can do to check that it works is you can then times the answer by 0.89, and there we go, we get 917, so it completely makes sense. Whenever we see a 3D shape in a question, you've got to ask yourself, is the question asking for a volume or a surface area? And that should be the first question that goes into your mind. Yes, it might be asking for something else, but those are the main two. We're looking at this, we're filling the swimming pool with water, so it's going to be a volume question. Now, way of approaching this is figure out what the shape is. Well, the shape is a trapezium-based prism. So we've got to first of all work out what the area of the trapezium is. So I'm going to draw the trapezium out first. And that height is going to be 2.7 that side, 5.3 that side, and 25 across. And I'll leave off meters because I know they're all in meters. But do check they are all in meters when you do this. So we've got to first of all work out the area. Now the area of a trapezium is half A plus B H. Now A and B are always the two parallel sides, and then the height is the one that connects them at right angles. So the height is going to be 25 there. And all you're doing is working out the average of the two bases, the 2.7 and the 5.3. We're going to times that by 25. Okay, so we'll crack our calculator out. 2.7. Some of you will probably see this straight away. So the first bit comes out as 4, because halfway between 2.7 and 5.3 is 4, and then times 25 is going to be 100. So the area is 100 meters squared. Now, for a prism, so volume, all you need to do is work out the area of the cross section, which is this bit here, the bit we just worked out, and then times it by how 3D it is. I think they call that the length officially, 15 meters. So the volume is going to be 100 meters squared times 15, which is going to be 1,500 meters cubed. So that's what the volume is, and it says the machine transports the water at a rate of 20 meters cubed per minute. So in 1 minute it's going to be 20, in 2 minutes 40. The other way of working this out, or the other way of thinking about this, is how many 20s are there in 1,500? So we can say time equals, so this is how much it's got to fill, and this is how much it does per minute. So on the calculator, 1,500 divided by 20, which equals 75 minutes. So it's going to take 75 minutes to fill the pool. I hope you've enjoyed that video, and don't forget, if you go onto onmaths.com, you can have a go at that paper again, and you can do it as many times as you want, and it's completely free, and if you sign up it saves your scores, blah blah blah. If you enjoyed this video, please click like. If you really enjoyed it, please click subscribe. Thank you very much for watching.